I'm getting tired of the same old picture of the web page. So here's my daughter Ella and Aaliyah. Hi guys. Okay, so back to the midterm practice. Okay, this set's going to start with number 15. Listed below are the errors in the predicted temperatures and actual temperatures of a certain city. Find the mean and median for the two samples, and then start talking about it. Do the means and medians indicate the temperatures predicted in 1 day in advance are more accurate than those predicted in 5 days advance, as we might expect? Or do we expect? Yes, we do expect that if you're predicting only 1 day in advance, that you'd be more accurate because you'd have the most recent or more recent data in than if you're predicting 5 days in advance, because you wouldn't have as much, of the data, what's the right word? Meteorological data that has come in. So let's go ahead and run them. Okay, so when I open it in StatCrunch, I already have both of them listed. I'll run the summary statistics, and I can run the summary statistics on both sets. Or at least I used to be able to. Let me hold Control. Yes, I can. Okay, so you just hold Control or Command, depending on if you're using a PC or a Mac. And I've got, well, I don't really need all this information, so let's not do overkill this time. Let's just do the mean and the median, and I'm holding Control as I select them both. If I want to select a range of them, I can click on the first one. Let's say I was clicking on standard deviation, and then hold Shift while I click on the next one, and it'll select the whole list of those between those. So I'm going to go back to this. Hold Control for both. Hit Compute. And the differences 1 day in advance turn out to have a mean of 0.5 and a median of 0. And the differences in temperature 5 days in advance turn out to be 0.2 and -1. Let me type those in and see what else they ask after that. Okay, so then do the means and medians indicate the temperature predicted 1 day in advance is more accurate than those predicted 5 days in advance, as we might expect? The root of the question here for us is really where are we seeing consistency? 1 day in advance or 5 days in advance, and how much consistency? And it's based off of this data. It's not based off of what we think we should see. So you'll notice that here, between the mean and the median, these are two different measures of center for the same set. It's this first set right here. We're only different by 0.5 of a point. And then for the 5 day prediction, we're off by 1.2. Now this is negative, so it starts from the left, and that's 1 whole point to 0, and then another 0.2, 1.2. So we are showing more consistency between in the 1 day earlier forecast rather than the 5 day earlier forecast. So I would say I'm going to look for something that's going along those lines. I'd say yes, the means and medians indicate predictions made only 1 day in advance are more accurate, or more, there's a higher consistency there. Okay, find the mean of the data summarized in the given frequency distribution. Compare the computed mean to the actual mean of 47.1 miles per hour. Okay, and alright. So this is normally quite a doozy of a problem if you're doing it by hand, and I want to give, like some respect to the old way. So I'm going to go to the formula sheet here, if it lets me. And we see listed here under Chapter 3, how to find the standard deviation from a frequency distribution. Oh, here we go. The mean from a frequency distribution is what I wanted to find. So here's the sample mean. What you do is you multiply each frequency by x. Now x is not x just some data point in the set. X is the midpoint of the corresponding class intervals. So you'll find the midpoint for each of the class intervals first, and then multiply by the corresponding frequencies. add all that up, and then divide that by the sum of the frequencies, which is really just n, right? It's the sample size. And that should seem very familiar now that we've started working on Chapter 5, because in Chapter 5, let me scroll down here a little bit, we do the sum of the frequencies times the sum of the random variables times the probabilities of each variable. Now, those probabilities already contain their denominator, right? So think of it kind of like a relative frequency. It already contains a denominator, so that's doing the exact same thing as what we're doing here. Except for this right here, frequency, sum of frequencies would be n, and that would be like each of those f's divided by that n each time before you multiply. And it works out to be kind of like an expected mean. Anyway, not to get too much into that, but that would be what you'd have to do. And then, we could do, here's an example from when I talked to you guys last time of finding a mean from a frequency distribution. Similar idea, except for instead there would be midpoints here and frequencies here. So I'm not going to do any of that. I'd either do the calculator, use the calculator, or I'd use StatCrunch. Now I'm not going to bother with the calculator either, because given that it's a test problem and I can already open this in StatCrunch, it's going to save me the most of the time, so I'll do it. Numbers are already entered for me. I think I do have to make a modification if I remember the video I made on this before. So I want to do stats, summary statistics, and grouped or bin data, but I think, looks like it maybe has no problem with that. I think last time I had to put a space between those. Oh, I know what it is. Sometimes this will show up, and I want to give you the heads up, with parentheses around each class interval. If it does, you got to either remove the class intervals, or the parentheses, or retype the intervals. So remove the parentheses or retype the intervals. And you can use the word to or this dash, the hyphen. So the bins are the speeds, and the counts are the frequencies. All I really need on this problem is the mean. So hit compute. There we go. It did all that very hard work. And once you've done this a couple times, you can truly appreciate that. And I've got an average of 46.95. I don't know what they want the nearest tenth over there. Okay, so I'm going to do 46. I'm going to do 47. So then the next question, go ahead and let's read that. Okay, so let's be clear while we're reading this that you understand what computed mean is. Computed mean is what we just did. We computed the mean from the summary information. And keep in mind, you're never going to be able to get the actual mean back from the frequency distribution, because it's lost. So you'd have to be told it or know from some other source. And look, they told us right here. Here's the actual mean, 47 and 1/10 mile per hour. So now we can compare our computed mean to that one by finding the difference and dividing. So let's go ahead and do that. There's the actual minus the computed, which comes from our summary statistics once we've already summarized into a frequency distribution. So we have 1/10 difference, and we're going to divide the actual, or we're going to divide that difference by the original, the actual. And we get, move the decimal over 2. We get a less than 1% difference. So they're very close. The computed mean is close. Okay, here's both of these to the actual mean, because the difference between the mean is more than, no it's not. I would go with D right here. And I think I have time for one without dragging this out too much, so let's try number 17 also. Good, this is one that I made some videos on earlier, so here's another video. The geometric mean is often used in business and economics for finding average rates of change, average rates of growth, or average ratios. Given n values, they're giving you the definition, by the way, right now for the geometric mean. This happens a lot in math problems where we tell you the definition of something and then we're asking you to use it. the geometric mean is the nth root of their product. So there it is. Instead of the arithmetic mean, which we normally use, where we add them all up, that's the arithmetic part, and then divide by the count, here the geometric mean is found by multiplying them all together and then taking the nth root. So the average growth factor for money compound at annual interest rates of 14, 18, 3% can be found by computing 1.14, and the reason why is because this is compounded annually, so at the end of the year, into the first period, before you compound, you've got all 100%, that's what the 1 is standing for, of your investment, and then you've got the 14% increase from this one, and then respectively you've got the 8% increase from the next one and the 3% increase from the next one, but that's why each time they have the 1 there also. So find the average growth factor. What single percentage growth rate would be the same as having 3 successive growth rates of 14, 8, 3? Does that result the same as the mean of I assume they mean the arithmetic mean of 14, 8, and 3? Okay, good question. I'll show my work on this calculator, and we're finding the geometric mean among 3 items. That means we only need the cube root, which actually is in the math button right here. Down here is cube root. Now if I was using any other root, I could just type in the root first, like 5 or 7 if there were 7 items, and then use number 5 right there, and it'll just use this generic root right here. So, but you have to have, in fact, you know what, let me just show you, in case you guys are using this kind of a calculator. If I wanted to use the third root, and I did not want to use the preset button, I could use the generic one, and that's how I would do it. I'd have a 3 written first, or 5 or 7, whatever it happens to be for the number of numbers that I'm using, the number of data points. And then here's my generic root symbol. Okay, and then I need some parentheses to get the product underneath this. And so I'm using the growth factors, which are the 100% and then the corresponding growth percentage. So that would be 14 in that case, and then 8 in that case, and 3 in that case. Now I close this with the parentheses here, hit enter, and there it is. So that's the number I'm going to put, and they want the nearest 4 decimals. So 10824. Okay, the single percentage growth rate that would be the same as having 3 successive growth rates of 14, 8, 3. Okay, that's here. They're saying essentially strip off the 1, that's the 100% representation, and just tell me what the percentage is. So in other words, multiply that remaining part by 100%. So as a percent, we're saying essentially 8 and 24/100ths of a percent. And it kind of makes sense, you know. That's looks like in the middle, even an arithmetic middle, you know, a regular arithmetic mean. In fact, that's what they want us to find next, right? The mean of blah blah blah. So let's try that. When using the TI-83 calculator to do this, make sure that you're either do it in its steps and you're summing up the numbers and getting that answer and then dividing by whatever the count is, or you're using parentheses. So be careful with your order of operations. I'm sure you are, but I just wanted to be safe myself. And in this case, I get, oh, you know, I didn't want the ones on there. Actually, I can just subtract it. But either way, let me show the calculation again. I was just trying to find an arithmetic mean of 14, 8, and 3 and see the, see if it's different. So I'm just considering the percentages there. Okay, so anyway, so 8.33, and I'll go to 2 decimals so they can be compared to the same level of accuracy there. The single percentage growth rate, is it the same or different? It is not the same, it's different. So this time I only got through 3 questions for this set. I'll go ahead and check our answers, see if we got them right. 15, 16, and 17 we're looking at. Lesson to be learned here on number 15. What was that question? So we did put everything in right. I must have misread something here. Do the means medians indicate that temperatures predicted 1 day in advance are more accurate than those in 5 days? They said no, the means and medians do not indicate any substantial difference in accuracy. I guess I should have run the numbers deeper. I could see a difference. This was 5/10 and this was 1 2/10. And that seems significant to me. Yeah, actually, I'll have to look back and see how they're reading it like that. So either way, so far, if you didn't see my other set, I got dinged on 13 and a partial ding here again. So let's see how I would do with these two. I'm just going to keep going because that's the way you do your test, right?